Okay, so welcome everyone. It is nice to see see the community coming back. Again, we are continuing the series of events with former speakers of JS Heroes, or what would have been 2020 speakers and trainers at JS Heroes. Tomasz was supposed to give actually a Svelte workshop back in April, and he was a speaker in 2019. For those of you who were at the event, or if you saw the recording where he spoke about testing with Cypress. And today he's actually going to present, or he's going to talk about his third passion, which is AWS, right? So yeah, I will let you introduce yourself, and you can start whenever you're ready.
Awesome. In the meantime, I'm going to start sharing my screen. So hello, everyone. My name is Tomasz Łakomy. I am a senior frontend engineer at OLX Group. And apart from that, I've been also teaching on egghead.io. So I have over 170 lessons recorded for that platform. And as Alex said, for the last, I think, year and a half, I've been quite interested in the world of AWS. Last year, I managed to get AWS Certified. I'm getting my second certificate like 10 days from now. And I'm very excited to talk to you about how can we build on AWS with TypeScript and Cloud Development Kit. In other way, how can we, web developers, translate our existing skills into the world of cloud? So I'm going to find my mouse because I'm fighting with it. All right. So before we start, I would like to quickly take you through my very first encounter with AWS, because I was not always somebody who knew a bit about AWS. Back in 2016, I was working on this. So I got hired for a project, and we were working on online casinos. And as you can imagine, like every single project I was involved in, it was a huge success because it was closed down 2 years later. In any case, we were working on this, and we got all those images for different casino games and whatnot. And I was told to, there you go, you have those images as a zip file or whatever. And yeah, just put those images on S3. And I remember thinking, what exactly is S3? What are we even talking about? Because like in the world of cloud and AWS, some people, I mean, in general, in the world of tech, sometimes people assume that just because they know something, it is obvious to everybody else, which cannot be further from the truth. Just to let you know, by the way, what the heck is S3? So what I'm going to do is that I am going to actually quote the Amazon S3 landing page. And I'm going to do that for a reason. So first off, Amazon Simple Storage Service, also known as Amazon S3, is an object storage service that offers industry-leading scalability, data availability, security, and performance. It is designed for 90.99911 of durability and stores data for millions of applications for companies all around the world. And the only reason why I've read those two long sentences is to kind of show you how sometimes difficult it is, because it is kind of like a different language, because this page is a very marketing oriented one, and you can read those and like, okay, what exactly is that? What does it mean? So if I were writing this from a developer's perspective, I would just say that Amazon S3 is an object-based storage. You can put your files in there, and that will be it. Luckily, I don't work in marketing. In any case, learning AWS is hard because you have all sorts of jargon, you have all sorts of new things that you have to learn, new topics that you have to discover. Amazon AWS documentation is famously lacking in some areas. It is getting better with all the time, but nevertheless, it is not trivial. Because when you log into AWS console for the very first time, you see this. And this is a screenshot from AWS console showing all the different services that AWS has to offer. And I remember looking at this for the very first time, and it is absolutely daunting. You look at it and like, what do I do? What do I do? Where do I go? There's just so many of it. And for the record, I am not blaming AWS for kind of showing all those services on their homepage, because it makes sense for the discovery. But nevertheless, this is not obvious. For instance, there's a service called Elastic Beanstalk, and you will probably not be aware, based by the name alone, what exactly is that. So it is not easy to learn. So there's lots of difficult concepts and ideas that you have to kind of acquire. So the question naturally becomes, why would you be interested? Why somebody who's been doing, JavaScript, HTML, CSS, why somebody like me would even be interested in learning about AWS? So I think there's a couple of things here. First off, I would like to quote this article from, I'm not going to pronounce his name because I will mispronounce it, but nevertheless, he writes that the cloud is eating the world. Notice that this article was written 8 years ago, because the cloud was eating the world, and it is still totally eating the world. And it is becoming so much more prevalent in the way we build software, in the way we ship products and services to our users and customers. And I think that this trend is not going to slow down any minute now. For me personally, it's also about keeping your eyes open, because as an engineer, you probably want to continue growing. You probably want to continue expanding your skills. And I'm not saying that you basically have to, abandon JavaScript, HTML, CSS, React, whatever it is what you are doing. I am just saying that it might be worthwhile just keeping your eyes open when it comes to new technologies. For instance, if you have been using Netlify, they have this idea of Netlify functions. So Netlify functions allows you to use serverless functions without even thinking about AWS. So I'm a huge fan of Netlify. I use it for basically everything. My own site, Łakomy.com, is hosted on Netlify. And the idea behind Netlify function is that you provide a piece of code, and they are going to run it on their infrastructure without managing any servers. So this, under the hood, it is actually using AWS infrastructure. And the reason why I'm mentioning this is that it may be worthwhile to you to kind of understand how those the higher level tools work under the hood in order for you to expand as an engineer, because perhaps you're going to join a Netlify functions team, and this knowledge about AWS will sure come in handy. So how do we build stuff on AWS? Because it is the cloud and there's all those different services. And how do we create things? So I want to build an app. I would like to have a database. I would like to have some functions that I can call. And I would like to have some storage for my static assets. How do I do that? Well, first up, you can do something that most people are using from the very beginning, and also in production when nobody's watching. They're using just the AWS console. And AWS console, it's a fancy way of saying, this UI in the browser. This is what is naturally being referred to AWS console. And as you can see, this is not the most intuitive piece of software. This is a new EC2 console. And the idea here is not for you to know what is going on, but notice that you are looking at this slide and your eyes don't know where to go, because there's just so much to discover. You're basically being hit with all of this information. And this is not easy for usage, because it's not intuitive, because you have to have some sort of acquired skills in order to use that. And secondly, for learning this stuff, well, there are surely better ways. Next up, you could use scripts, right? Because looking back at this, if you wanted to have an infrastructure where you have a database, again, you have some functions, you can probably click it through the AWS console, just configure it in the UI itself. This can totally be done, but how about we do it again? Are you going to remember a year from now what steps did you take in order to create your app? Probably not. You could write it down, and I don't know about you, but I have been writing documentation, and unless you really care about the documentation, it is going to be outdated the minute you hit save. This is what always happens with documentation. It becomes outdated. So the idea is to use scripts instead. So maybe we don't need to write documentation. Maybe we don't need to click through the UI. Maybe we can just automate it with a script. And I don't know about you, but my experience with automation sometimes is that take a look at this dude. Like he's looking at, this is what it's supposed to look like. Why are you building this? Well, because the script is outdated and we forgot to update it and nobody knows how to run the script anymore. Or the person who wrote the script quit 2 months ago and we actually have no idea how to run it again. Well, this is not easy. This is not trivial. And that is partially why this idea of infrastructure as code has been born. So the thing is that maybe we don't have to tell people how to build stuff. Maybe we can just tell the machine what we want. In other words, infrastructure as code is this idea that we are going to kind of codify the infrastructure in AWS that we want to get. Think of it as React. When you are using React, you are returning a piece of JSX from your component. So you're returning a div, a header, and whatnot. You, as a developer, you don't really care how exactly the browser is going to render this div, this header. You are basically saying to React, give me those elements. I don't care how you do it, just do it. Infrastructure as code is roughly similar. We get to describe what we want, and we get what we want. So in a file, in code, we get to tell AWS, by the way, my app is going to require those exact resources. Please provision them for me, create them for me. I don't care how you're going to do it, just do it. And additional benefits include things like version control, because there are no scripts anymore. There's no more, implicit documentation that you have to show to somebody in order to configure the stuff. You can just take a look at a configuration file and it is going to show you what is being done. So you can version control it. You can do code review, which is especially useful because if somebody is going to introduce a change that is going to increase your AWS bill by 100%, you probably want to know about this. And another idea is predictability, because if you have a declarative file which is describing your infrastructure as code, if you're going to run it once, 2 times, or 500 times, you are always going to get the same results. Whereas if you assigned a human to repeat the same steps 500 times, I assure you that there will be mistake down the road. This is just how humans are. And there are multiple tools of kind of creating stuff in the cloud using code. So the kind of, maybe not the oldest, but kind of like the basis of how we build stuff on AWS using infrastructure as code is AWS CloudFormation. So CloudFormation is actually 2 things. It is this language, this YAML-based template language that we are using in order to provision and create resources in AWS. And as you can see, I don't know about you, but this is not intuitive. This is not easy to read. So what's happening here is that it is going to create an S3 bucket. So as I mentioned earlier, an S3 bucket is kind of like a container for files. And it is going to call it my awesome JSHeroes bucket. And there's also all sorts of settings. And those files get large, like in hundreds of lines, if not more. And this is not easy to write. This is not easy to maintain. But nevertheless, this was a groundbreaking kind of innovation when CloudFormation came out. I was not doing anything cloud related at the time, so I cannot tell you very much. But nevertheless, I think it's an important discovery that we get to write what we want and get what we want. Later, there was something called Serverless Framework. And the way I see it is that this is JavaScript, this is jQuery. So this is another kind of layer of abstraction over CloudFormation. It is also a YAML-based template, but this is much simpler. As in, this template is not doing the same stuff as the CloudFormation template that we saw before, because it is doing so much more than this. So it is actually going to provision a serverless function with an API gateway and all kinds of different things. I don't want to go into too much detail into what it is doing, but just know that basically with Serverless Framework, we get to create our own applications in the cloud with much less code that is much easier to maintain. And there are also plugins and whatnot. But you may be looking at this and thinking, well, okay, YAML infrastructure as code. Okay, I am a JavaScript engineer. I want to learn this stuff. I don't want to learn a new programming language. I've been working very hard to learn JavaScript, to learn TypeScript, and I would like to continue using those skills. By the way, a fun fact is that YAML is actually somewhat a programming language. So like if somebody has this critique that YAML is not a real programming language, this is not really true, because apparently you can use loops and conditionals. Don't try this, but it is possible. And if you do, don't sue me. In any case, AWS Cloud Development Kit allows us to have all the benefits of infrastructure as code, code reviews, version control, and whatnot without kind of leaving this safe bubble of TypeScript. So it is an open source software development framework that allows us to define cloud application resources using familiar programming languages that we love or at least tolerate in some cases. So I would like to show you a slide that I've borrowed from AWS, and I hope that they don't mind because it's excellent. So we can see a bunch of different things here. First up, take a look at the center of the screen. It's just code. You may not know what it is doing because it's a rather complicated infrastructure, but nevertheless, you can recognize some things that you are used to. So there's a class, there's a constructor, there's const, we are creating some variables, we are using those variables, there are objects. So this is much more familiar to a JavaScript/TypeScript developer. And notice, and we're going to see that during the later in the talk, that whenever somebody is actually using CDK, there's type completion in the editor. So if you are not sure how to configure something, your editor is going to help you. So you can have quite a lot of, how should I say that? You can learn quite a lot about AWS without even leaving your editor. All right. And there are also a number of programming languages supported. So you can use Python, you can use JavaScript, TypeScript, Java, C#, and there's also apparently a support for Go programming language coming soon. I very much like this idea of being able to use the same programming language for multiple ways. So front-end, back-end, and now infrastructure. If you are very happy with your editor, you can keep using the same editor. You can keep using the same tools for infrastructure code. By the way, I'm going to stop sharing because I am a host of this meeting apparently. I think there are people that are trying to join. So just let me add them real quick. Okay, so I'm going to resume. Where was I? There you go. Okay, so CDK Patterns is one more thing why you might be interested in CDK as a developer, because maybe you don't want to reinvent the wheel. Like some apps are not, rocket science. So many apps just require some database. So many of us are basically shipping to-do apps for a living. That is okay. Every app has a create, read, update, delete pattern. So there's this idea of pre-existing patterns that you can use in order to make your life easier. So for instance, if you want to ship your React app to AWS, you can download a pre-made CDK pattern and just use it in order to ship something in the cloud. And there's lots of those different patterns. And in a way, you can basically run npm install your desired architecture. So if you have an image of what you would like to build on AWS, and it is a rather common problem, you can either reinvent the wheel, which is not terrible. You're going to learn lots of new things along the way, Or you can use an existing pattern that was made by somebody who probably has more experience in that than you, and you also get to, well, use that. If you create something new, interesting with CDK, you can share it with others on NPM because it is just JavaScript. In fact, let me show you. So I realized that I am physically unable to do a talk without a demo. So what we are going to do, I would like to show you a couple of interesting features of CDK. So I have a brand new directory. There's nothing in here. First up, I'm going to initialize a new project. So when we run CDK init, it is going to tell us that we have a bunch of different templates. So you can create a new application, you can create a new construct. I'm going to tell you what construct is in just a minute, or a simple application with some constructs already installed. So I'm going to create a new app. So I'm going to run CDK init app, and language is going to be set to TypeScript. And as you can see over here, you can also use C#, Java, Python, and also JavaScript. For the record, you are probably not going to write so much code over here. So like if you are not familiar with TypeScript, I would recommend using TypeScript anyways, because you get type completion, which is highly useful over here. In any case, we have created a brand new project. I'm going to open up my Visual Studio Code and show you what we've got. So the vast majority of your CDK code is going to live inside of lib directory. So over here, we have a fresh CDK stack. And again, this should be roughly familiar if you are a TypeScript JavaScript developer, because we have imports, we have a class. Notice that this directory that I created this project in, it's called JSHeroes, and that is why it automatically created a JSHeroes stack. It is going to extend a CDK stack, so it is a class that represents a stack in the cloud, so a set of kind of resources that are connected together. And here in the constructor, we're going to create our own resources. So first up, what do we want to have in our app? It's basically up to us. So by default, CDK comes with a set of like core functionality. And if you want to have more, well, like any TypeScript JavaScript project, we have to install them. So I'm going to run npm install, and I'm going to install a bunch of dependencies. So I would like to use Amazon S3, so S3 buckets for storage. I would like to use AWS Lambda for serverless functions. I would like to use API gateway in order to be able to talk to those Lambda functions through HTTPS or HTTP. And I'm going to also create a DynamoDB table. And notice that you only have to install the things that you're going to actually use in your app, in your infrastructure. So that's actually kind of interesting, because you get to install whatever you want. So first of all, I'm going to import everything as S3 from AWS S3. You can see already that I have some code completion enabled. And what is S3? So if I were to run s3.bucket, this is something that is called a construct. So there are a couple of different levels of constructs in CDK. A construct is a representation of something in the cloud. So there are very like low-level constructs. Imagine that it is just a single resource, so like database table or an S3 bucket. So that means that it's something that is basically like a single thing in the cloud, but there are also higher level constructs. Because the idea is that you can compose those constructs together. So if I were to implement a complicated infrastructure pattern for my company, for my organization, I could actually publish this to our both internal or external NPM and have other developers in the same organization kind of reusing the same functionality, the same constructs, and so on. So this is highly useful, because why we use JavaScript frameworks? Because we want to have some problems implemented for us. We want to have them abstracted away from us. I don't want to do DOM manipulation anymore. This is why I am using React instead of jQuery, even though I absolutely love jQuery. It's still in my heart. In any case, an S3 bucket it takes 3 arguments. First up is a scope. So the scope is this, because we are creating this bucket in the scope of this stack. The secondly, the argument is the ID. So I'm just going to call it my bucket. And third up are the bucket props. And take a look at this. If I enable type completion, so like control plus space, we can see all kinds of different settings that we can enable in this bucket. So this is what I've meant, that we can use CDK in order to not only build our stuff, but also to learn about the cloud. Because if you are roughly familiar with S3, you have this idea that you can use it to store files. Well, maybe you didn't know that you can enable encryption on it. And by just browsing those different settings, you can learn quite a lot about S3 and all kinds of different services. And one more thing is that CDK is based on best practices. So there's a lots of things that are kind of decided for you. So if you are building something, you don't have to specify every single option. In fact, in order to create an S3 bucket, you don't have to configure anything. It is just going to create an S3 bucket for you. So I'm going to open up my terminal and I'm going to run a deploy command. So we have to run CDK deploy in order to deploy our stack. I am also passing in my profile because I have a bunch of AWS profiles on this machine. So I am passing a CDK one, but by default, you wouldn't have to use it. Just to let you know, what is this CDK over here? This is a command line interface that comes with the CDK. So CDK is not only, this idea that you can create stuff using TypeScript, but also a command line interface for you to deploying stuff, for you to be able to deploy things in the cloud. And basically, in order to install CDK, you have to run npm install global CDK, and it is as simple as that. There's some configuration involved, but you can find more info in the documentation. All right, so we can see that our JSHeroes stack has been successfully deployed. There was not much in it because it was a simple S3 bucket. So I'm going to go ahead and go to my AWS console, and we can see in CloudFormation. Why in CloudFormation? Because I mentioned earlier, CloudFormation was this YAML file, this huge one that was uneasy to read. Cloud Development Kit, CDK, is built on top of CloudFormation. So when you think about it, you write TypeScript code that is going to be converted into JavaScript, that is going to be converted into CloudFormation template. And this CloudFormation template is going to be used to provision your infrastructure in the cloud. But you, as a developer, the only thing that you have to actively think about is TypeScript. And how cool is that? Like, so many things are abstracted away from you. In any case, if I click on my JSHeroes stack here in the CloudFormation console, what I can see is that in the resources section, there's an S3 bucket, which was created for us by ourselves. So we didn't have to do anything. And there we go. We have our very first resource created in the cloud without leaving our editor. I'm going to test something. I'm going to upload a new file to this bucket. So let me see what do I have on my desktop. Okay, I have this image of a cookie. So I'm going to hit upload in order to upload this file to the cloud. And there you go. Right now, I can take a look at this image of a cookie. So let me click over here. And here we have something that is called an object URL. So if I click on that, I'm going to see my cookie, and I'm not going to see my cookie. And why is that? Because teaching you some AWS kind of in between, an S3 bucket by default does not have public access because you can store some potentially sensitive data in there and you don't want to make it public by default. And this is what I meant when it comes to sensible kind of defaults over here, because I didn't have to configure whether this bucket is open or whether it's closed. AWS thought that it's better to assume that I want to keep things closed. And if I open it, I have to just specify an, what was the name? I've actually forgot the name. So let me just take a look. Okay, there you go. Public read access. What does it do? Grants public read access to all objects in the bucket. By default, it's set to false. I'm going to set it to true. There's one more awesome feature of CDK. One of my favorite Git commands is git diff, because it allows me to see what am I about to push to main or master branch. CDK has something similar. CDK has CDK diff, and it is going to show me what is the difference between things that I have already in the cloud and the things I am about to push in the cloud. And it is important to review this stuff, because imagine that this my bucket had HR documents in it, like sensitive data. You probably want to be warned if you are about to make it open to the public, because right now I'm going to allow a get object action to be taken by everyone. With that being said, I'm just going to deploy it. This is going to take a second. It's going to ask me if I am comfortable deploying those changes in the cloud. I am totally comfortable doing that. So it is going to create a CloudFormation template. So again, this giant YAML file that you don't even get to see in that example. All of this is being taken care for you. All right, so it's managed to successfully deploy. I'm going to refresh, and there you go, we have a cookie. And this is just a simple example, but I think it shows how powerful this is and how easy it is to learn this, to learn more about AWS through CDK. But I'm going to do some more stuff. So what I would like to do is, let me take a look on my list. I'm going to create a Lambda function. So just so you know, a Lambda function is a serverless function. So the idea is that we are going to provide some code. I'm going to create a main.ts file. And over here, I'm going to paste some code because I am lazy. So there you go. I'm going to remove this part. And I am also going to remove this for now. Okay, so the idea behind serverless Lambda functions is that I'm going to just provide a piece of code that I want to be executed. And I don't have a server. I don't want to have a server. I want to be able to run this code. So the idea behind serverless Lambda functions is that you don't have to think about servers. You just have to provide a piece of code to AWS Cloud, and whenever this function is going to be called, you will only have to pay for the duration of this function. So if you have a server under your desk, you have to pay it 24/7, all year long. With serverless, you don't have to do this because you only care about providing the code, and you are going to be billed only based on how much your code is actually being executed. There's also a free tier. So like the first million invocation of a Lambda functions are completely free. So unless you have some significant traffic, you're not going to pay anything at all. With that being said, I'm going to do a couple of more things. So I'm going to import a couple of things over here. So let me just remove DynamoDB for now. So I am going to import a Lambda because this is a construct that allows me to create Lambda functions and push them to the cloud. And I'm going to also import something that is called an API gateway. To put things simple, an API gateway is a door. It's a door to the cloud. So through API gateway, you can actually call Lambda functions that live inside of AWS Cloud. Because remember, a cloud is just somebody else's computer. Okay, so I'm going to create a new Lambda function. So I'm going to call it my Lambda. It is going to be a new Lambda function. Notice that it is basically telling me what to do. I'm going to call it, my Lambda. And here I have a bunch of props that are not marked by the question mark. Therefore, I have to provide them. So first up, there's code. So where is the code? So code is actually located in code from asset because I have to get it from somewhere. And I'm going to provide the name of this folder. So this folder is called Lambda functions, and I have to provide the same thing over here. It is still complaining because I have to provide two more things. Handler. So notice that I have called this function that is going to be executed a handler. This is a common convention in the world of serverless and Lambda that the function that's going to be actually executed should be called a handler. Well, it's generic enough, so I'm going to keep calling that. So the handler is main.handler. So what is it saying? That go to Lambda functions directory, and inside of it, you're going to find a file called main, and I would like you to invoke a function that is called handler. One last thing, we have to provide the runtime. So a Lambda function can be written in all sorts of different programming languages. And I'm going to show you a list. So you can use .NET, you can use Go, you could use Java, you could use Node.js, different versions, Python, Ruby. And if you really want to, you can also do something that is called a custom environment, if I remember correctly. So you can basically write functions in COBOL or Haskell if you really wanted to, but I don't think I don't recommend it. So this is a Lambda function, and it's easy as that. So we are just going to provide some code. And if you want to call it, we're going to create a REST API in 2 lines of code. So in order to create a REST API, I'm going to use this API gateway, which again, a reminder, is basically a door to the cloud. I'm going to create a Lambda REST API. Apologies, my editor seems to be a bit wonky. I'm going to close those, and this, I'm going to call it an endpoint. And the only thing I have to provide is the handler. So which function is going to be executed after I hit an endpoint? So to keep things simple, I'm just going to use this my Lambda. And in the meantime, I'm going to provision that. So I'm going to run deploy and talk you through it again. So it's going to ask me to confirm a bunch of actions because I am deploying a Lambda function, and I am also allowing this function to be called from the internet. Because, well, by default, everything that you deploy in AWS is going to live in AWS and it's going to stay there. So by default, things don't really have access to the outside internet. And that is by design. Because imagine that you have a function that is not meant to be public. So it is not meant to be called by HTTP request because it's doing some kind of internal work for you in your cloud, for your cloud resources. You probably want to ensure that it is not going to remain, it is not going to be open. So a couple of more things is that similarly to an S3 bucket, you also have all sorts of options for a Lambda function. And I'm not going to go through all of them because that would be like way too much. But for instance, you're going to see it later that you can also provide an environment for the Lambda function. So you can provide environment variables, and there's all sorts of different things here. One more thing is that you could also provide a memory size. So a Lambda function, basically the way it works is that you're going to rent some sort of compute capacity in the cloud. And how much you're going to rent, well, it depends on how much you want. By default, you're going to get 128 megabytes. But if your function requires more, because for instance, you're doing some very like computation sensitive stuff, like you are analyzing huge amounts of data and you need more RAM, well, you could get up to 3 gigabytes of RAM. Of course, you're going to get charged significantly more for doing that, but nevertheless, this is still an option. One last thing, since I'm talking about Lambda, why not? Lambda has a maximum duration. So as I mentioned, your function is going to be called only when it's necessary, and you don't have to think about servers, but your function cannot last forever. So because of that, Lambda functions by default have a timeout of 3 seconds, which is more than enough for like simple things. You call Lambda function, it talks to a database, the database is going to get some data back. That's it. But you can extend it up to 15 minutes, which, well, honestly, it's quite a lot. Like if you are not done in 15 minutes, you could probably think about some other solutions to your problem. With that being said, our stack has been successfully deployed. What do we have here? We have an endpoint. So we have something that I can actually call. So I'm going to call this endpoint, and I'm going to get an internal server error because I screwed something. And I wonder why. This is absolutely not meant to happen. Okay, not terribly happy about that. Let me see, what did I do wrong? In any case, I'm going to take a look at something else. So I'm not going to try to call this function again. I'm just going to confirm that it exists. So I'm going to go back to my stack, and I am going to go over here to resources. And we can see that with those 2 lines of code, with only those couple of lines of code, I have managed to create all sorts of different resources. So I'm going to take a look at my Lambda function over here. Let's see what's going on. So this is not the Lambda function because, oh, there you go. This is the Lambda function. So we can see, again, all sorts of different things were created and configured for us. And this is a connection that we have right now. Oh, okay, I know what happened. So I would like to show you something. On the top of my notes, I have this. Remember about npm run watch. Do you know what is not running right now on my machine? npm run watch, exactly. So the thing is that before we could build this, this is written in TypeScript. So I have to convert it to JavaScript because TypeScript is not supported by AWS Lambda. So I can run either npm run build that is going to create TypeScript files for us, or I could run npm run watch that is going to watch for those changes and compile them in the meantime. Nevertheless, I would like to show you that you can actually build a serverless function API. So I'm going to deploy it again and show you over here what can we see when it comes to the Lambda function. Because I think what is important to understand about CDK is that not only you get to create resources in the cloud, but you can also create different connection between those resources. So this has created a Lambda function, and it is connected to an API gateway. Alternatively, we could, for instance, have a function that is triggered by S3. So imagine building something like an user is going to upload their profile image to an S3 bucket that is going to call a Lambda function that is going to generate a thumbnail of this image, and it's going to store it in another S3 bucket. You can build that with TypeScript without kind of like learning additional programming language, without learning Python or any other, more backendy programming language. And honestly, I'm a huge fan of it. So right now it's going to work. Yay, awesome. We have a hello JSHeroes. This is something that we have defined over here. Okay, so I would like to do one last thing. So I'm going to import a DynamoDB table. Why? Because, well, building an API is awesome, but storing data is even better. Like every single application probably has some sort of like persistent storage. And serverless applications are no different. Like, okay, awesome, you can call a Lambda function, it's going to do your stuff, but nevertheless, you want to store this data somewhere. And DynamoDB, which is a NoSQL database provided by AWS, is a perfect solution for that. So because I am a bit behind on time because I was fumbling with my code being broken, I'm going to copy that and explain it quickly. So it is going to create a new DynamoDB table, which I'm going to call table because I'm not very original. And each DynamoDB table has to have a partition key. So to quickly inform you, a partition key is something that uniquely identifies an item in DynamoDB. In my case, it is going to be an ID of type string. And that's it. Imagine, I'm not sure if you have like experience with MySQL or other databases, but creating a database from scratch could be a bit of a hassle. And right now I get to create a cloud-based DynamoDB database with basically 3 lines of code. And this database is going to scale massively for me without any input whatsoever from my side. And I am only going to pay for the data that is going to be actually stored in that database. So you will no longer have to pay for keeping an empty database running on some server in your basement somewhere. I'm going to also do one more thing. I've told you earlier that CDK is not only about creating resources, but also about making connections between resources. So by default, for instance, a Lambda function cannot talk to this database, which makes sense, right? Because I don't want everyone to have access to the data in my database. That includes also my colleagues, and that includes also different Lambda functions that I'm going to create. But I would like to have this function return the data from the database. How do I do that? Well, I could just do this: table grant read data my Lambda, and that's it. This is a single line of code, and with that single line of code, I have granted this my Lambda function the privileges to read data from this table, and that's it. I was honestly blown away the first time I saw it. I will have to do one more thing in the Lambda function. So I'm going to quickly copy and paste that over here. So this Lambda function is a bit different now. So I'm just going to remove that. It's going to make TypeScript unhappy, but this is absolutely fine for that part, because I forgot actually to install two things, because it's complaining about the lack of AWS CDK. So I'm going to install that quickly. And let me took it back. It is going to complain about types. Oh, there you go. We also have to install types for the stuff that we are using, because it is TypeScript after all. So right now, there we go. It is not complaining anymore. I'm going to quickly walk you through this function. So it is going to use AWS CDK. So AWS CDK is a software development kit, not to be confused with Cloud Development Kit. Again, I told you names in AWS are not consistent, to say the least. So this is going to take a table name from an environment variable, and it is going to use a DynamoDB document client, which is basically the way how we can use DynamoDB database from JavaScript. And this function is just going to get all the items in this DynamoDB table. So it's called get all to-dos. I'm going to actually rename it to get all items, because this is much more convenient in that case. And it is going to get those items and return them as a JSON. One more thing, how do we take a look? On the right-hand side, we have this Lambda function. On the left-hand side, we have this our stack. We have to somehow pass the table name as an environment variable to our Lambda function. How do we do that? Well, luckily, there's a relatively simple way of doing that. I just have to use this. So I'm going to pass in an environment variable to my Lambda function, and the only thing that I have to pass in is the table name, and this table name is going to be equal to table name, and that's it. Like I don't have to configure stuff. I don't have to deal with environment files. I just get to create variables and assign those variables to different variables. This is what I love. I am a TypeScript developer. I want to continue working with TypeScript. I don't want to write config files and whatnot. So I'm going to deploy that quickly. And it is going to take a bit longer than before, because it has to create a DynamoDB table, which is I know it's going to take probably a minute or so, which again, it's much faster than the stuff that you are kind of used to if you are not doing things in the cloud, because buying a server, configuring MySQL on it is going probably to take you significantly longer. So this is going to create this stack. It's rocking. So I'm thinking, what else can I share with you in the meantime? So of course, this function over here, this is not perfectly ideal. this Lambda function, because I am not like handling errors. I am only going to get all items on every single request. But if you want to have a single function for saving data into the database or getting the items from the database, you can generally create an entire REST API in a single Lambda function. You can totally do that. This is absolutely up to you. Although I would probably recommend having different Lambda functions per action that you want to take. So I would imagine a function like get items, put items, delete items, and whatnot. Okay, this is actually taking significantly longer than I thought. I don't think this is my internet though. I think this is, live demo gods not being terribly happy with me today. So let's just give it a minute. It's going to probably, okay, this is 3 out of 11. But this operates on Windows rules. So remember when we are like installing Windows 98, it says that it's either between 2 weeks or 20 seconds remaining. You never know. Okay, right now it's managed to successfully push this stack to the cloud. So I'm going to very quickly go over here, refresh the resources that we have in our stack, and I'm going to look for our DynamoDB table. We can see that over here. I'm going to click on that in order to see our fresh DynamoDB table created. I have an invalid URL, which is funny because I clicked on the URL from the cloud. This is new. This is new. This is not something that I have seen before. So I'm going to, okay. I think that AWS is right now introducing a preview of the new DynamoDB console, and that this is actually a bug on their side. So this is interesting. In any case, this is the JSHeroes stack table that we have created just right now. Right now, we have 0 items in that database, but I'm going to very quickly create an item. So I'm going to basically put an item over here. So I'm going to create an item with an ID of 1, 2, 3. Create an item. And there you go. We have a single item in our database. I know this is not exactly thrilling because it's only 1 item, but you can probably imagine that you can put all sorts of data in this database. It is a NoSQL database, so that is why I don't have to create any schema for it. And right now I'm going to do a moment of truth event. I'm going to curl our CURL. I'm not sure how you pronounce it. I'm going to curl this URL in order to get all items from our DynamoDB table. There you go. So it did look for all of the items. It did get the item of the ID of 123, and the count of the items was 1. Just for the record, this is a scan operation that we are using over here. It's going to go for your entire database. So if you have like millions of files, you probably don't want to get all of them in a single batch because it can be rather expensive. But nevertheless, for a small example like this, this is exactly valid. So to kind of conclude this demo, I would like to quickly review what we just did in just like a couple of minutes from 0 to hero. We've learned how to create an S3 bucket. We've learned how to make it public. We've learned how to create a Lambda function from scratch. We've also learned how to define an environment variable for this Lambda function. We know how to create a Lambda REST API in order to be able to call this function from the internet. We know how to create a DynamoDB table, how to set up a partition key and what is a partition key. So it is going to uniquely identify items in an array. And we also know that we can define kind of connections between resources in CDK. So we get to tell that this resource has access to that resource. So this Lambda function can write data to this DynamoDB table. That is quite a lot. And I am honestly very proud of all of us that we've managed to do it together. I mean, I did it, but you were here for emotional support, and I appreciate that. I would like to conclude this talk with this idea that with CDK, you can kind of become a fuller stack developer. So you get to use TypeScript for front end, jQuery obviously, but nevertheless, TypeScript for front end, backend with Node.js, and infrastructure. And this unlocks quite a lot of possibilities. I was actually watching a talk earlier today that you can also do continuous delivery with CDK. So you can use CDK in order to create continuous delivery pipelines for your CDK apps. And this is like one level above all of that. And I'm really looking forward to see how many things are we going to be building with CDK a little while from now. CDK is still relatively new, and I'm very excited about it. In fact, I would like to quickly plug in that I did a course on egghead.io, which is called a Build an App with the AWS Cloud Development Kit. It guides you from zero to hero when it comes to Cloud Development Kit. We are building stuff roughly similar to what you saw right now, but with a lots more kind of context. There's a lot more going on, and you're going to learn an awful lot about all kinds of different AWS servers. Highly recommended. This is the best thing I ever done when it comes to content. With that being said, I would like to thank you for listening, and I would love to hear if you have any questions.
Thank you. That was really nice.
Awesome. Happy to hear that.
And we could clap, but it would be awkward probably for everyone that claps in their own room. But
no, it's fine.
Nice.
I actually miss it,
Yeah, for me it was really interesting because I had no prior experience with any of these, and it's quite surprising to see how easy it is to do everything. Like back in the days, if I can say that, like you would probably have to rely on the AWS console or your just inner knowledge of what service to use and when.
Exactly.
So this looks like it's a much more accessible kind of approach for especially for developers with no prior infrastructure knowledge.
Yeah.
Do we have any? Yeah, sorry.
No, go ahead. Go ahead.
No, if you have any questions, if anyone has any questions, I wanted to.
I'd like to ask a question.
Sure.
First, thank you very much. Like, this is amazing. I'm blown away because I'm building an app right now with only Amplify and a little bit of tweaking in the console. So this is a huge improve, and thank you very much for the time.
No
and I wanted to know that in the moment when you made the bucket public, could you also, with the CDK, make only a folder inside the bucket public?
Okay, so this is actually not encouraged by AWS. Like S3 buckets have different ways how you can control kind of the access to the contents of the bucket. So there used to be things that were called, if I remember correctly, bucket policies. So in a bucket policy, you could, for instance, because I know what you're saying, like you have a single bucket and you have a couple of files that are meant to be public and some of them are meant to be private. This is still supported by AWS, but for kind of legacy reasons. So you rather want to have separate buckets for public and private data. You can have up to 1,000 buckets in an account. So this is not a huge deal that you have to create a separate new one. And honestly, like managing which files should be public and which files should be private in a single AWS bucket can be, I assume, probably kind of a bit messy. This is why I'm very happy that I am a developer and not a security data compliance engineer.
Thank you, man. That helps me a lot. Thank you.
Yeah. Speaking of Amplify, there's an awesome talk on YouTube which I watched yesterday about how you can combine AWS Amplify with CDK. I'm going to find it in the meantime and paste the link in the chat. If you have any more questions, I'm also here.
Yes, I do have a question, and thank you. It was great presentation. So I'm wondering regarding the tools and the development lifecycle. I remember when SAM was launched, there was quite a challenge, for example, to develop locally or test locally, and even the plugins for different IDEs. So I'm just wondering, from your experience so far, how easy is it today, for example, to use CDK locally, to test locally, and and also, how ready are the plugins for different IDEs? I saw you were using Visual Studio Code. Is there already a good extension for Visual Studio, IntelliJ, and things like that?
So I'm going to talk about Visual Studio Code because this is my idea of choice. I think that it is much better when as opposed to some. So a couple of things here. I feel like CDK is much more focused on like developer experience. So people who are writing CDK themselves, like the CDK team, they're using Visual Studio Code, and there's actually a VS Code extension for CDK, which makes quite a lot of things a bit simpler. So for instance, you can see the contents of your CDK stack after you deploy it within the VS Code editor. When it comes to testing locally, you can, so there's a couple of things. You can actually write tests for CDK, which is a thing that I could probably do in another talk because I didn't have the time right now. So you can write tests in order to see kind of whether your stack works as intended. You could also run your functions locally, but this is going to use SAM under the hood. I am unable to find a better way of doing that right now. But I think that this is going to change. I think that AWS is going to kind of adopt CDK as one of the kind of mainstream ways of building stuff in the cloud. And things that we have right now in CDK, I think this landscape is going to be so much more different in a year from now. Because like even the CTO of Amazon has said, in public on his Twitter that CDK is a game changer. And honestly, I kind of agree with that. Even though I don't work for AWS, I am not involved. But still, I am very happy to kind of see the progress there. So to sum up, I think it's not 100% perfect right now, but it is going to get so much better.
Okay, thank you. We probably need to write an article, CDK is eating the world.
Yeah, honestly, you can quote me in 2 years. In 2 years, CDK is going to be the mainstream way of building stuff in AWS.
Yeah.
2022.
Okay, thank you very much and good luck with the certification in 10 days.
Oh crap, I have to study, yes.
If not, I also have maybe one question, more of a curiosity. So you mentioned the Egghead course. For people that are just starting with this, other than the course, what other resources should they take into consideration, like the official docs, stuff like that? Like where would you go for any?
Okay, so a couple of things. The CDK documentation is great because it is a relatively new service, so they are trying to keep things fresh. So the official documentation is a great place to start. There's also a cdk.dev stack. So if I remember correctly, this is the address, cdk.dev. This is the Slack for the CDK community. There are also many people who are active on Twitter. Also, a great way to learn more about CDK is to visit cdkpatterns.com. This is the site I was showing in the slides, where you have all sorts of different kind of patterns that are already implemented in CDK. So you can see not only how you create very basic stuff, but also how you can leverage those skills in order to build something that is much bigger and much more production ready. And there are also quite a lot of videos on YouTube. So AWS, they are doing AWS Tech Talks, and CDK is featured rather frequently in there. And if you are interested, there's also one more thing. A month ago, there was a CDK day. So there was a whole conference online, obviously, about CDK. And the videos are already on YouTube. So if you are interested in that area, if you want to learn more in a video format, I strongly recommend you check it out.
Cool. Thanks. I think these are very useful resources for everyone that wants to get started from somewhere or
exactly.
just needs some sort of references as they're working. Okay. Anyone else? Any other questions? Okay, if not, I guess we can call it a meetup. Thank you, Tomasz, for taking the time.
No problem. It was a pleasure.
Yeah, looking forward to actually seeing you in Cluj in person.
Oh boy, me too. Looking forward to it.
Future. And yeah, thank you all for joining. I hope you enjoyed this. And yeah, we'll see each other at the next event.
All right. Cheers. Have a good day.